Have you ever heard the expression, there are three types of lies? Lies, damn lies, and statistics. This stems from the fact that statistics can indeed be misused and thus induce false results. Here are a few ways where statistics can be misrepresented. The first one is suspect samples. 3 out of 4 dentists recommend this toothpaste. Whoa, that seems like a great toothpaste, but how many dentists have actually been interviewed for this claim? If there were only 4, this result could be due to chance alone. If 100 dentists had been surveyed, results might have been different. Do these dentists have any link to the toothpaste maker, say by receiving free samples? Did they volunteer for this study? It's always a good idea to find out not only the sample size, but how it was selected. Ambiguous averages are also misleading. If you look at this sentence, it says that the average salary in the education profession is of $75,000. That's a good salary, but as we'll see later, there are 4 commonly used measures that are called averages: the mean, the median, the mode, and the mid-range. These averages can differ significantly, and whoever knows this can easily choose the one that supports their position. Changing the subject. Beware of the use of values without percentages or vice versa. Although the figures presented here are correct, without adequate context they can be misleading. Always ask yourself which measure best represents the data. Now, 50% less fat. That seems like a healthy choice, doesn't it? What some forget to mention is 50% less fat than what? Always ask yourself, compared to what? Eating these vitamins may help reduce your risk of heart diseases. Notice the use of the words may help. These claims may be true, but the choice of words implies that there is no guarantee involved. Now here's one that comes out really often, the misleading graphs. You'll often see graphs in the news, on the internet, in textbooks, etc. But beware, a lot of graphs have little elements that can make them quite misleading. Let's take a look at this one, for example. Notice how the y-axis doesn't start at 0? Bars are judged by their respective lengths, and in this case, we're only shown part of the bars. So it looks like the value has more than doubled between the second and the third bar, when it was more of a 25% increase. Also, even though the bars are evenly spaced, the time between each event is not equally dispersed. So it looks like the value of 84 billion was very lengthy, when in reality this was for less than a month. Our last misleading item is the survey question. The way a question can be worded may influence the answers. It's fair to say that a large majority of the population is in favor of limiting greenhouse gas emissions and thus would agree with the first question. But the response could be very different if the second one was asked. So it's one thing to collect data and be aware of how it can be misleading, but it's another and more useful thing to actually organize this data and then represent it in various ways. Let's say that the professor simply jots down all of the results of the midterm exam in his class like this. Although there is some information we can gather from this, it looks quite hodgepodge, and it is difficult to get to any conclusions. As such, we need to organize it, and we will do a frequency distribution of this data. A frequency distribution is the organization of raw data like we have here in table form using classes and frequency. Each raw data value is placed into a class. The number of data values contained in each class is the frequency of the class.